So this is just meant to summarize what we've done so far. With these two special right triangles, 45, 45, 90, and 30, 60, 90, there are certain relationships that will be constant. Regardless of the actual lengths of this side, or length, possible lengths, I guess is what I wanted to say. If it's opposite the 45-degree angle, then the other side opposite the 45-degree angle has to be the same. So whatever this side is, this must be identical. And the length of the hypotenuse, hopefully you've noticed that this will always be the square root of 2 times whatever that length is. On the MCAS, they give you a formula sheet. On the SATs and the PSATs, they give you a formula sheet. They used to call these toolkits. One of the things that has often been on all of these is the relationship between the sides in a special 45, 45, 90 triangle. And they usually give it to you this way. Whatever the length of a leg is, a leg meaning side that's not a hypotenuse, if it's a 45, 45, 90 triangle, then this length and this length must be identical, and the hypotenuse will be that length x times the square root of 2. In a 30, 60, 90 triangle, they usually describe it this way. The shortest side will be opposite the smallest angle. The smallest angle is 30, so the side opposite that, let's just call that x. Whatever it is, the hypotenuse is going to be twice as big. And what we figured out in some of the previous problems, examples in the discovery activities, is that this length, the length opposite the 60-degree angle, think of it as the third side, not the shortest one, not the hypotenuse, which is the longest one, but the one in the middle. Middle length, middle-sized angle are opposite each other. This one will be whatever x is times the square root of 3. Guaranteed. All right. There's only one small problem with representing them this way, is sometimes they don't give you the shortest side length. If they gave you the shortest side length, then you'd be able to say the hypotenuse is twice as big, and go back to the shortest side length. The side opposite the 60 is that length times the square root of 3. What they very often do is they start with the hypotenuse. And whatever the hypotenuse is, I'm just going to call this 1, because very often it's 1. Oops, go away. If this is 1, and we did this in the previous exercise, in the previous video, turns out that this length will be the square root of 2 over 2. And obviously this has to be the same. Not sure why my keyboard keeps popping up. Over here, if the hypotenuse was 1, stop it, that means that this will be 1/2, half as big. And this length will be the square root of 3 over 2. These relationships are constant. Now, if the hypotenuse was twice as big, all the other sides would be twice as big. If the hypotenuse was 4 times as big, all the other sides would be 4 times as big. This is the nature of similar triangles, is that if you use a scale factor to make either one of these triangles bigger by a scale factor of 2 or 3 or 4, you'd be scaling up all of the side lengths. So if the hypotenuse were to become 10, then these lengths would be 10 times larger than they're written right now. That's it. Use those ratios, use those relationships between sides to answer the problems in the practice exercises.